Hello everyone. So today let's continue our class on probability theory and a little bit of statistics. Okay. So last time some student told me that it's a bit unclear about what I'm writing on the notes. So let me just today let's do a little bit of so let's just briefly review what we have learned in last class. Okay. So we're talking about probability distributions. Let's think of a simplest example. This random variable x, okay, it can take two values, either 0 or 1. So this set 0 and 1 is the sample space of this random variable. And the probability distribution of this random variable x is simply the probability of x equal to 0 and the probability of x equal to 1. For these two numbers p0 and p1 to be probabilities, they should satisfy these conditions. Okay, first of all, p0 and p1 should be positive but less than 1, and their sum equal to 1. Okay, so this defines the probability distribution of this random variable x. Okay, this is a simplest example. It's called a balloony distribution. Okay, but more often we will deal with probability distributions of continuous random variables. Okay, for continuous random variables, the most important example I will cover in the class is the normal distribution. Okay, so so now let's think of random variable y. Okay, for example, and it is distributed as a normal distribution with mean mu and variance sigma squared. Okay, so what's the meaning of this notation? It basically says that first of all, y is a random variable. Okay, and the value of y can be taken from any real number. Okay, this is the symbol for real numbers. So basically, it equals from negative infinity to positive infinity. Okay, so you have this the whole real line is so the possible value of y can be any real number in on the real line. Okay, and for a continuous random variable, we use PDF or probability density function and the cumulative probability function to uh, represent its probability distribution. So the probability density function, okay, the PDF, prob of y equal to This is the probability density function, okay, of normal distribution. It looks like of this shape. It's bell-shaped and symmetric. The meaning of probability density function basically tells you, okay, so the area under the probability density function, okay, the area, say for example, between -2 to -1, this area is the probability that this y random variable lies between -2 and -1. Okay? So this is the meaning of probability density function. And we also have the cumulative density, cumulative distribution function. Okay? F y, which equal to the probability of this random variable y less or smaller than uh, y. Okay. So if give you the probability density function, okay, suppose you have this probability density function and you want to know the probability that y is less than y. Okay, so then it should be the area of all this region, right? All this region. So if you are familiar with calculus, it's basically the integral from -infinity to y. I'm use y bar, okay, to distinguish between a generic y and a specific value of y. Okay, equal to this. Okay, so this is basically the density function, right? So this is the way how we can represent a continuous random variable. Okay, and normal distribution should be can be one of our most important example here. Okay, and last time we also talk about other moments of a distribution, right? The skewness and the kurtosis. Okay, so and that we have see the Bernoulli distribution. Okay, also we have see the normal distribution. Okay, other examples, if you want, you can study them by yourself. Okay?